Thank you for joining us on this session on geometric series. It's C2 in the Cambridge examination course. In this session we're looking at a question that requires the use of a geometric series. Now if you looked at your formula sheet that you collect that is provided for you, you will find, if I can find it, you will find certain questions that can assist you with a geometric series question. So let's just highlight those first. You will see on your formula sheet geometric series, and one of those rules I'll start with is this one. You will see this rule, and you will see this rule. And I would hope that you understand each variable. We could swap this order r to the power of n and r minus 1. And sum of infinity is over 1 minus r. Of course, r, the absolute value of r has to be smaller than 1. So it has to be between -1 and 1. Now these are the rules which you can use. This is for the nth term. This is for the sum of all the terms from 1 to n, all the sum of terms, and this is the sum of an infinite number of terms if n was infinity, and often I think in the next question we may even have the requirement to use those rules. So let's have a look at a question that requires us to use those. Now I have to get my calculator out of my bag. Right, so get the calculator ready. Hopefully it lasts, because my batteries are getting flat. Make sure you put good batteries in your calculator before you go into the exam. That'll help. Okay, so the first question says a geometric series has first term, which is u1, the first term, a equals 360. So the first term is 360. The common ratio is 7 over 8, and that is less than 1. Giving your answers to 3 significant figures where appropriate, find the 20th term. So we're looking for the 20th term where u is 20. And if we refresh our memory of the nth term, then the 20th term will be a r to the power of n minus 1. And if n was 20, it is 20 minus 1. So we're looking for the number which is a times r to the power of 19. Replace a with the first term, which is 360. Since a is the first term, and r is the common ratio between terms, what each term is consecutively multiplied by. R is 7/8 to the power of 19. Wow. So 3 significant figures. Let's find out what the calculator says. 360 times 7/8 to the power of 19. My calculator is saying that that is equal to 28.47446075. Now, 3 significant figures. 1, 2, 3. So 28 point, and this is going to round up because it's a 5. This number is a 7, so that's going to go up to 5. So 28.5, that's the 3 significant figures. That's the 20th term, 28.5. So it's being reduced by a factor of 7/8 each time. Find the sum of the first 20 terms. So now we've got the second rule, the sum of 20. Now keep in mind the sum of n was a 1 minus r to the power of n over 1 minus r. Therefore, the sum of 20 is a 1 minus r to the power of 20 over 1 minus r. So it's a 360, 1 minus r to the power of 20 over 1 minus 7/8. I'm just going to, I'll write it. I'm just going to go straight to 1 over. So 360 times 1 minus 7/8 to the of 20 over 1. So 360 times 1 minus, open bracket, 7/8, close bracket, power of 20. Okay, that's in brackets for the numerator. And divide by 8, and times by 8, because it's quicker. 2680.678775. Some of the first 20 terms to 3 significant figures were appropriate. Well, here's one, there's another, there's a third. We've already got a 0. We could leave that as 0. If it was a number, we could round it off to the nearest 10, because therefore that would be 2, 6, 8. There's your 3 significant figures. So the sum of the first 20 terms is 2,680 for 3 significant figures. And finally, find the sum to infinity, and that was the third rule, which is a over 1 minus r. So it's 360 over 1 minus 7/8. 360 divided by 8, same as 360 times by 8, and we've got 2,880. And that is the sum to infinity of this series. Well, it didn't take a lot of time if you apply the rule straight away. Let's have a look at our answers. And we've got 28.5, 3 significant figures. A, R to n minus 1. So notice it's 19, it's not 20. And so 28.5, and there we have the first answer. So the first answer is correct. And the second answer, we're looking for 2,680. And the second answer, 2,680. We've already got the 3 significant figures. And so we've got 2,680. So yes, we just have to tick there. And finally, we wanted the sum to infinity, and they've got a over 1 minus r, 2,880, and 2,880, and we've got that correct as well. This is a simple question on geometric series. I would hope that you would find other questions very similar to this question, give them a practice, and until we see you again or talk to you again, just remember, stay happy.